Okay, you can read my explanation up here on function notation. This is the third video on functions for section 2.1 of my college algebra lecture series. Okay, so this is function notation. Read f of x. It means f is evaluated at x. So basically, you have a set of rules here that says you take 3 times x plus the absolute value of x. So whatever x is, you're going to do these rules to it. So let's say x is -2. Well, to evaluate this, you could say f of -2, and that just simply means this set of rules is going to be applied to -2 instead of x. So 3 times x would be replaced with 3 times -2. Absolute value of x would be absolute value of -2. And of course, then you can simplify it easily. That would be -6 plus 2, which is -4. Here's another one. F of x is, the set of rules are x cubed minus x plus 3. And so if we evaluate that at -3, it looks like the little 3 is missing there. So f of -3 would actually be -3 cubed minus -3 plus 3. And so you would get -27 plus 3, which would give you -24, plus 3 would give you -21. Here's another function. S of t is equal to 3t over t minus 5. Here's one where I'm using t instead of x for my independent variable, and I'm using s instead of f for my dependent variable. Okay, so if I evaluate this at t equal 3, then I would get s of 3 is equal to, the top is 3t, so the top would be 3 times 3, and the bottom would be 3 minus 5. Everywhere there's a t, I replace it with 3. And I get 9 over -2, which is -9/2. Okay, if I took the same function and evaluated it at t equal 5, then I would get 3 times 5, which is 15. Okay, and then I would have 15 over 0, but that's undefined. So now you kind of see why 5 is not in the domain of this function. Now sometimes we can evaluate a function at an expression instead of a number. So let's say I wanted to evaluate this quadratic function, x squared minus 4x plus 2, at x equal 2a minus 1. Well, f evaluated at 2a minus 1, I need to replace x here with 2a minus 1. And so that would be this. And then I need to replace x here also with 2a minus 1, so that would be here. And then of course I just bring the plus 2 down. Now, you have to square the binomial, so you get 4a squared minus 4a plus 1. Here you distribute, so you get minus 8a plus 4, and then you bring down the plus 2. And then finally we just collect like terms. 4a squared minus 4a minus 8a is minus 12a, and then 1 plus 4 plus 2 is 7. And that's it. That's how you evaluate that function at 2a minus 1. Now, let's talk about a difference quotient. This is especially important if you have to take a calculus class. The difference quotient, I'm going to use h. In calculus, they might use a term called delta x, but we're going to stick with h because it's easier to use. So the difference quotient is defined to be whatever the function is evaluated at x plus h minus the function and then divided by h. You can use 3 steps to get this difference quotient, and I think it's easier to do it that way. So to get the difference quotient, remember I ultimately want to figure out what this expression is. So I'm going to start with the first part of it, f of x plus h. So you got to be given a function. So I'm going to give you this function, 3x minus 5, and I'm going to say find the difference quotient for 3x minus 5. So we're going to do it in 3 steps. The first step, we're going to figure out what is f evaluated at x plus h. So that means I take x here and replace it with x plus h. So instead of 3x minus 5, I have 3 times x plus h minus 5. And then you get 3x plus 3h minus 5. That's the first step. The next step is to do the difference. That's the numerator. So I'm going to do f of x plus h minus f of x. Well, f of x plus h I've already done, right? See, that's why I wanted to do that first. I already have that. So here it is, f of x plus h. And then I want to subtract f of x. Well, f of x is just the function itself, so I'm going to subtract that. Now you got to remember to distribute. So you must distribute here. So when we subtract, we're going to have minus 3x plus 5. Now what happens in these is most of the time some terms are going to cancel. So you're going to have 3x minus 3x cancels, and you're going to have minus 5 plus 5 cancel. So all you're left with is 3h. So then in the third step, we take what we got from step 2 and we divide it by h. And then that gives us, see, this is actually the difference quotient form right here. So I take what I got up here, which is 3h, and I divide it by h. And of course, 3h divided by h over h is 1, so my answer is 3. Now when I said h over h is 1, that's only true if h does not equal 0, because 0 over 0 is called indeterminate. It's an undefined form. So I just want to make sure you're aware of that. Okay, let's do one more difference quotient. This time we'll do one for a quadratic function. So here I have x squared minus 2x is my function. So let's do f of x plus h. Well, it says I need to do x squared here, so I replace x with x plus h, and so I have x plus h quantity squared. And then I have minus 2x, but I have to replace the x with x plus h, so I have minus 2 times x plus h. And again, you know how to square a binomial, so when I square x plus h, I'm going to get 3 terms. I'm going to get x squared plus 2xh plus h squared. And then this is going to be 2x plus 2h, but I'm going to subtract. So I actually have minus 2x minus 2h. Okay, so that's the rest of it. So that's f of x plus h. Now, what I must do is I must subtract the function here. Okay, so let's ignore this right here. I see I left something out here. Okay, let me fix it and come back. Okay, so anyway, this right here is f of x plus h. Okay, and actually I'm supposed to subtract from that f of x in this step, and I left off the f of, minus f of x. So here you'd have to insert this, minus f of x. So there's, all of this is f of x plus h, and then this is minus f of x. So what we got to do here now, and I already simplified this up here, so technically I could have just ignored this and said, okay, we know from step 1 that this is f of x plus h. So this is this portion. Okay, and then minus f of x, well, this part is minus f of x. Okay, now notice that minus x squared, when you distribute that minus, you get minus x squared plus 2x. Okay, now notice look at the x squared and the minus x squared. They're going to cancel. And then look at the 2x and the minus 2x. They're going to cancel. So all I'm left with here in this step, and I don't know why I didn't actually write that, is 2xh plus h squared, and there's one more term, see, minus 2h. So in that second step, I have those terms. Okay, now so that's the second step. Now the third step is to take that and divide them by h. So I take that, which is right here, and I divide them by h. So I just divide h into each term. 2xh divided by h is 2x. H squared divided by h is h. And minus 2h divided by h is minus 2. So your difference quotient would be 2x plus h minus 2. And again, you can do that as long as h does not equal 0. Okay, next I want to introduce the concept of increasing, decreasing functions. Now, most functions are either increasing or decreasing over an interval. Now, some functions can be constant over an interval, which I'm not covering here. Constant just means it's a horizontal line. But let's take a look at number 11 here. This function actually is increasing over one interval and decreasing over another interval. So when I look at the graph here, we're going to see that the function is increasing from 2 to infinity, and the function is going to be decreasing from negative infinity to 2. Let me show you that. See, here is the graph. Notice that, let's say negative infinity is that way. Okay, so let's say we go from negative infinity, we keep going to the right, keep going to the right, keep going to the right, and we're going down until we hit 2. And then once we hit 2, we're going to increase. So we're increasing basically to the right of 2, and we're decreasing to the left of 2. So you're decreasing from negative infinity to 2, and you're increasing from 2 to infinity. On the other graph, this function is never decreasing. It's only increasing. You're increasing over the entire domain. So as you move left to right, you're increasing over the entire domain. And so that's basically, what we're talking about when we talk about a graph is increasing or decreasing. So I could have given you more complicated examples, but I just wanted to give you the general idea here. Okay, let's wrap up this section and talk about even and odd functions. An even function, a function is even if when you evaluate it at f of negative x, you get f of x. Okay, so go over here. Let's start with b, because that's the order I did them in. This function here, if you replace x with negative x, in other words, calculate f of negative x, well, negative x to the fourth is the same as x to the fourth. Negative x quantity squared is the same as x squared. And you just bring the 3 down. So basically, you end up with what you started with. So, in other words, f of negative x actually equals f of x. So that's an even function. And you might remember that even functions are symmetric with respect to the y-axis. Okay, you get an odd function if f of negative x equals minus f of x. In other words, if when you replace x with negative x, you get opposite of what you started with. So let's take a look at this function. Well, this function, if you replace x, if you evaluate f of negative x, you're going to replace x with negative x and in both places. Well, when you cube negative x, it's actually, when you cube a negative, you're going to get a negative. So you're going to get negative x cubed. The cube root of negative x is the same as the cube root of negative 1 times the cube root of x. And the cube root of negative 1 is simply negative 1. And so you end up with minus negative 1 times the cube root of x, which is just plus. Minus a minus is a plus. So you get minus x cubed plus the cube root of x. Well, if you compare this with the original function up here, you'll see it's just opposite. It's just opposite, because up here you have plus x cubed minus the cube root. Here you have minus x cubed plus the cube root. So basically here we've shown that f of minus x actually is the same as minus f of x. So therefore f of x is an odd function here. And over here we showed that f of minus x was equal to f of x. So therefore f of x is an even function. Now, not all functions are even nor odd. I mean, there's plenty of functions that don't have either one of these qualities. Okay, so that takes care of that. We'll get into some graphing of some functions in the next video.